Everyone, welcome to another video. Today, last video, we talked about expected value, and the expected value or the mean of a distribution is the center. That's the center of the distribution, what we expect to happen. What we're going to look at today is the variance and the standard deviation. That tells you how wide the distribution is. Is all of the data, all of the probabilities, are they all clumped together around the expected value, or are they really, really spread out? And so if they're really spread out, you're going to get a large variance, okay? You get wide things and a large standard deviation. But if they're all clumped together really tightly around the expected value, then you're going to get a small variance and a small standard deviation. Okay, so the formula for this one, up there on the screen, the variance of a discrete random variable is equal to the expected value of x squared. I'll talk about that in a second. Take away the expected value of x squared. And hopefully you see the difference between those two things. One is the expected value of x squared, and the other one is the expected value of x all squared. Okay. When you're finding e of x squared, it's exactly the same, sort of method as finding e to the x. In other words, multiplying together the x values by the probability that that x value happens. But in this case, it's x squared. So you've got like an x squared in there instead of x. So the only difference between the two formulas is that for ex, you have x there. For ex squared, you'll see it's got an x squared there. So you'll see on me when I do an example of that one there. Okay, so that's the variance. Okay, now standard deviation, it's something you've probably more heard. Standard deviation is the square root of the variance. Okay, so just some other things there. The variance can sometimes be written as sigma squared. Okay, so sigma squared is the variance, and another way you can write standard deviation is just sigma. Okay, so sigma is the standard deviation, just in case you see that notation. So just a reminder, mu is the mean or expected value, and sigma is standard deviation. Okay, so just two symbols that you might see. When I say might see, almost definitely see. Okay, so to find the standard deviation, all we do is square root the variance. Just a property of the variance, just like we talked about the properties of if you have a linear transformation of the expected value. If you've got a linear transformation of the variance, what happens is that the variance doesn't even care about sort of any plus b, which makes sense. If you're adding a number to something, it doesn't change how wide the distribution of that discrete random variable is. So that plus b doesn't even come into consideration. But that a, the constant that's in front of there, that comes out the front as a squared. So that gets squared. That's because what's happening is the standard deviation is getting squared, and we'll go through that in the example in a second. Okay, so just a couple of definitions there, but let's bring it together with an example. So let's say we've got this discrete random variable here. The possible values for x are 0, 1, 2, and 3, and you see the probabilities of each of those things occurring are there. So let's go and find the expected value. So I might do it below because I think I'll start over here. Okay, so a expected value of x is equal to, if you remember, expected value of x, we multiply all these things by all these things and then add them all up. Okay, so let's do it. So 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2. So that will be my expected value. Let's sort it all out. That's just 0. That's 0.3 plus 0.8. That's 0.3. That's 0.8. And that there is 0.6 plus 0.6. So what is that? 1.1, 1.7 I get. Okay, so we don't know what this random variable is about. We've got no context here. Don't know, but what that means is that the most common value that you're likely to get is 1.7. Okay, so for all those, my expected value, my average value that I'm expected to get there is 1.7. So somewhere in between 1 and 2 is the most common. Okay, so somewhere in there if I was going to draw them on a number line. Okay, there's my expected value of x. Second, let's find the variance. Okay, so remember the variance is equal to expected value of x squared, and we just had that formula up the top there. Take away expected value of x all squared. Okay, so we've got that bit there. We just figured out what that's equal to. That's 1.7. But we haven't got that bit there, x squared. So let's go and figure that bit out, okay? So expected value of x squared is equal to, and what we do, let's get that table back in there, it's going to be 0 squared times 0.1, okay? So see how we're squaring all the x's now, and then multiplying by the probability, plus 1 squared times 0.3, plus 2 squared times 0.4 plus 3 squared times 0.2. All right, and we'll evaluate this. 0, that goes away again. That one there, that's still going to be 0.3, doesn't change. That one there is 4 times 0.4, which will be 1.6. 1.6. And 9 times 0.2, so that'll be 1.8. 9 times 0.2, yep, that's right. All good. And so expected value of x squared is 0.3, so 1.9 plus 1.8 is 3.7. So expected value of x squared is 3.7. Let's put it all together. Therefore, variance of x is equal to expected value of ex, which is 3.7, take away the expected value of x squared, so 1.7 squared. Now, up until now, I've been doing everything by hand. Just going to do a calculator here because I don't want to do that. You don't know how to get to a calculator. So I've got 1.7 squared, 1.7. I haven't used this calculator for a while, 2.7, and I'll negate that and then add, I don't know if that was the best way to do it, 0.7 equals 0.81. So I get 0.81 as my variance using that. Okay, so there's my variance. That bit's done. Let's now move on to part C, where I want the standard deviation. Okay, so part C, standard deviation of x is equal to, remember, square root of variance x. So that's just the square root of 0.81. I'm just going to do it without calculators to show you, sort of, maybe if you have an exam or something, you can't do it. I haven't got a calculator, and so the square root of 81 over 100, so that's 9 over 10, so that's 0.9 is the standard deviation. Okay, so that just means how much what's the standard distance that any sort of any data value lies from the expected value from the mean. Okay, and D is the variance of 3x plus 1. What's the variance of 3x plus 1? Remember up here, that one there, the variance, if you have some transformation of x, that whatever's in front of the x comes out the front as a squared. So this is equal to 3 squared times the variance of x, which is 9 times, what was the variance of x? 0.81. Can't do this one in my head. I really don't want to. Yeah. What? Oh, no, not today. Not ever. 9, sorry, times 0.81, and so that's 7.29. 7.29. So that's the variance of 3x plus 1. I hope that all makes sense. That's sort of how variance and standard deviation are calculated when you've got a discrete random variable. All good? I'll see you in the next video.